Hey, good Maya Killa, good morning. I scared this morning. Yeah, I heard some mumblings that Russian guy, Vladimir guy, I heard that he's in the area. And somebody told me that he's coming for me today. Oh, children, you got to pray. Because I'm scared and I can't run very fast anymore. My beard's too long, it might get in the way. Oh, that would be terrible. But you know, we got to do something about it. I brought my shrift along today. I'm going to preach to him. I'm going to tell him about the love of Jesus. Yeah, because he is a bad guy. He needs to be saved. He needs the Lord. And I'm going to tell him all about it someday when I get the chance. But right now I'm scared and I'm afraid I'm going to have to run away. I keep looking out the windows and out the door and I don't know what to do. But we'll try to get into our lessons, okay? Yeah, let's go to our math lessons and we'll try. Oh!
Hey, you crazy bishop, you!
No! Off the lever! Off the lever!
Help me, please! Come here, you! I will get you! Unser Vater, du bist im Himmel, dein Name wird geheiligt, dein Reich komme, dein Wille geschehe auf Herrn, wie es im Himmel.
Morning, Reagan. Morning, Megan. Morning, Logan. Good morning, Israel. Hope you're ready for this lesson. Lesson 3 in your math today of 809. Notice that we are talking about significant digits, etc. And I'm going to go through the rules with you on page 10. So open your books and let's start. Page 10. Okay. So the first rule they give you on page 10, we're talking about significant digits in any kind of a number. We have to know how many are significant so that we know where we can round to the most precise amount. So the first rule they give you, it says every non-zero digit in a measurement is significant. So read that again. Every non-zero digit in a measurement is significant. So any kind of a number measurement, if it's not a zero, that number is always significant. Okay, that's pretty simple. The second rule, the bottom of page 10, says sometimes zeros are significant digits. Sometimes they're just placeholders. So we have to figure out whether the zeros are either placeholders or if they're counted as digits. And the rule is that zeros preceding the first non-zero placeholders are not significant. Okay, so the first example they give you, 0.0043, it only has two placeholders, or two significant digits. Because these zeros that are preceding the first non-zero, okay, you see this? These are not significant. So it's just the 4 and the 3, two significant digits. In 0.23, it's just 2, again. In 0.1, you just have 1. The zeros in front, okay, preceding the first non-zero are not significant. All right? So we always remember that. on the top of page 11, you have your next rule. Zeros that are between non-zero digits are always significant. So 607. The zero's between the 6 and the 7, so it counts. It's 3 significant digits. 30,201, the next one they give you. So again, count everything in between the 2 non-significant digits. So you have 5. And 5,003 would give you 4. So if they're sandwiched, if a non-zero digit sandwiches the zeros count as significant. You understand? Okay. And the next one they give you, it says any zero to the right of a non-zero digit in a number that contains a decimal point is a significant digit. Okay, so if the measurement has a decimal point, like the first one they give you is like this, typically this zero wouldn't count. This zero does not count because it's in front of a non-zero. But in this case, being there's a decimal here, we have to count the zeros to the right of the non-digit zero, or of the, can't think of the word, significant digit. Okay, so we have to count it. So this has a total of 3. And the same thing if you have like this. Again, anytime you have a decimal point in the measurement, you have to count the zeros that are to the right of the non-significant, or the non-zero. So this is 1, 2, 3, 4. Okay? And 0.00430. In this case, these are in front. We don't have to count them. But this one's behind it. It's a decimal, so it's 3. 3 significant digits in that one. Okay, so again, read the rules. There are a little bit more to remember, but read the rules. The next one they give you on page 11 is sometimes a number will end with 1 or more zeros followed by a decimal point. So the decimal point comes at the very end. In this case, the zeros before the decimal point are significant digits. So like 3,000 ending with a decimal point, count them all. It's 4. 450 ending with a decimal point, it's 3 significant digits. And the last rule there is, in a number without a decimal point, zeros to the right of a non-zero digit are not significant. So if it's no decimal point in the measurement, then all the zeros to the right of the digits are not counted. Okay, so 79,000, there's no decimal, so we don't have to count these zeros. Now if it would be like this, a decimal there, then we'd have to count all 5 of them. Understand? You get it? All right, wake up there now. Let's not go fall asleep in my class. All right, so I'm going to give you a few examples, and I want you to tell me how many significant digits there are in this number, okay? So can you read this? Whoops. Start again. 0.0067500. How many significant digits are there in that? Logan? I can't hear you, so I don't know. But remember, one of the rules is, there's a decimal, but the zeros in front of the non-zero we don't have to count. But being there's a decimal, we do have to count the zeros out behind. So we have 1, 2, 3, 4, 5. If you said 5, then you are correct. Good job. If you did not say 5, okay, what about this one? 0.048. How many significant digits are there? Same rule applies. The zeros don't count, so we have 2. Okay, it's a decimal. What about this one? 509,800. It's not a decimal, so we can cross out the zeros at the end. We don't have to count them. We have 1, but we have to count this one because it's sandwiched between 2 non-zeros. So we have a total of 4. Do you understand? Are you nodding your head? Thumbs up? All right. Have a good day. I hope you have fun. And maybe next week sometime, you can go with me down to witness to that Amish bishop and that crazy Russian dude. All right?